everyone, in this session we will be discussing solution of producer consumer problem with semaphore. Means, as we have discussed in the previous session, in the producer consumer problem there are inconsistency and data loss problem. Okay, means there is no synchronization between the producer and consumer. That's why producer and consumer leading what, my dear friend, inconsistency or loss of data. So here we will try to provide the synchronization between producer and consumer to avoid inconsistency and loss of data with the help of semaphore. So here we will use what, both type of semaphore, counting semaphore as well as what, binary semaphore. Okay, counting semaphore as well as what, binary semaphore. So I am going to discuss the solution for producer consumer problem with semaphore. Solution for producer consumer problem with semaphore. With semaphore. With semaphore. Okay, understand? Understand, my dear friends? So as I told you, my dear friends, we will use both counting semaphore as well as what, binary semaphore, as well as what, binary semaphore. Okay, in counting semaphore we will use two variable. First is what, empty, and second one is what, full. Okay, second one is what, full. So from the naming convention you can understand, empty will give you what, empty variable will give you what, my dear friends, number of empty slots. Okay, number of empty slots. And full variable will give you what, number of filled slots. Number of filled slots. Okay, number of filled slots. So in initial number of filled slots is what, number of filled slots is what, 0. So as I told you, full variable value is what, my friend, 0, because it will give you number of filled slots in initial. Okay, in initial there is no filled slot. Okay, and empty will give you number of empty slots. Number of empty slots. So in initial, when any slots is not full, okay, when anything is not in the buffer, then empty will is what, n, means empty size is what, the buffer size. Empty slot is what, the buffer size. Okay, understand clearly? And binary semaphore, we need to initialize the binary semaphore with value of 1, with value of 1, as we have discussed in the binary semaphore. We need to always initialize the binary semaphore value with 1, okay, as we have discussed in the binary semaphore. Okay, so now I am going to execute the code, my dear friends. Now I am going to execute the code. Okay, so this is the code, my dear friends. This is the code for the producer and consumer. This is the code for the producer and consumer. And as we have discussed, okay, as I have mentioned the full producer code in the producer consumer problem and full consumer code in the producer consumer problem. So here we will execute this code only. Okay, and we are going to see how this semaphore can provide the solution for the inconsistency and loss of data. From the inconsistency and loss of the data means how, with the help of semaphore, producer and consumer can synchronize. Okay, producer and consumer can synchronize. So here we have a buffer, and the size of this buffer is suppose is what, size of this buffer is suppose, my dear friend, this is 8. Okay, so index of the buffer is what, 0, 1, 2, 3, 4, 5, 6 and 7 and suppose at any point of time in the buffer, we have 3 items A, B, C. Okay, you can consider anything x1, x2, x3. Okay, here I am considering A, B, C. Okay, so here we have in variable, here we have this in variable. Okay, and here we have this out variable, So invariable is used by the producer to know at which empty slot producer can produce the next, okay, item, okay. And through this out consumer can know from which slot consumer can consume the item from the buffer. So consumer can consume the item from the buffer from 0 slot, and producer can produce the next item at slot number 3. So here 3 will come. And there is one more thing, that is what, my dear friends, count. That is what count. So count will give you what, my dear friends? Number of items in the buffer at a particular time. So how many items here we have? How many items do we have here? 3. Listen me carefully. So now I am going to execute. This produce item. Okay. Now I am going to consider the case 1 in which producer is producing the item. Okay. So buffer. So full is what, my dear friends? Here full. Counting schema for full value is what? Full value. How many slots is full, my dear friends? 3. And empty slots is how many? 1, 2, 3, 4, 5. How many? 5. Okay. So you can consider 5 empty slot is there and 3 full slot is there. 5 plus 3 total buffer size. It will give you what? Total buffer size. Okay. Means 8. Okay. So when producer will produce the item, then it will execute this code. Down empty. We need to down this empty. Okay. Means in the empty we have 5. We need to down this empty. Means it will become what? 4. Down S. Here I am taking what? Binary schema 4 is what? 1. Okay. Down S. So we will down this 1 by 0. Okay. Buffer in equal to item P. Buffer in equal to, in case first, suppose producer want to produce item D. Okay. So buffer in equal to item P. Okay. Buffer in equal to item P. We need to put this D into the buffer. Okay. Okay. Buffer in equal to item P means in next empty slot is 3. So at the place of 3 we need to put this item D. Okay. Then what we need to do? In equal to in plus 1 mod n. Okay. So 3 plus 1 is what? In equal to 3 plus 1 mod n is what? 8. So 4 mod 8. So what? Remainder will come 4. So in variable replaced by 3 from 2 4. Okay. So next empty slot is what? 4. If producer want to produce the item. Okay. Then up of S, we need to up this S binary schema 4, and up of full here 3. We need to up this by 1. Okay. So it will 4. So at this point you can check, after producing the item, at this point you can check what is the total size of the buffer? 8. And full is what? Here is what? Full slot is what? 4. Empty slot is what? 4. So 4 plus 4 is what? 8. Consistent. Okay. There is a consistency. Okay. Now consumer comes and consumer want to consume an item. My dear friends. Okay. So consumer want to consume an item, and out, consumer is used what? Out variable to know from which slot it can consume the item from the buffer. So out variable value is what? 0. So from 0 slot it can consume the item. Okay. So it will perform what? Down full. Okay. Down full. So we will down this full 3. Down S, we will down this S 0. Item C equal to buffer out. Okay. So we will consume this item C from item A. Okay. From here. Okay. From here. Out equal to out plus 1 mod n. Okay. So we need to update this out also. So out equal to out plus 1. So 0 plus 1 mod n equal to what? 8. 1 mod 8. equal to 1. So this out updated from 0 to 1. Okay. Now out will become what from 0 to 1. Okay. Then is what, my dear friends? Up of s. Up of s. Okay. We need to up this s. Okay. Up of empty. Up of empty, my dear friends. We need to this empty by this need to up this empty. Okay. So it will become what, 5. Okay. So clearly there is a consistency. You can check from here. How many empty slot in the buffer? 5. 1, 2, 3, 4, 5. And how many full slot in the buffer? 1, 2, 3. Only 3. So now this way we can provide the consistency and we can remove the loss of the data. Okay, we can remove the loss of the data by using the semaphore. Okay, or you can say that we can provide the solution of producer consumer problem with using what, my dear friend? Semaphore. With using what? Semaphore. Now you, I hope you understand clearly the solution of producer consumer problem with semaphore. Okay, so please note it down if you want to note it down. So I hope you noted down, my dear friend, this okay, whole things, whole points. Okay,